Hey everybody, it's me, John Park, and I'm here in my workshop. And I think we're all set. In fact, we're even successfully, I think, broadcasting to Facebook today. So hopefully you're checking us out on Twitch, on Periscope, YouTube, and now Facebook. So I am going to be working on a pretty cool project today, just in time for Halloween. And first I just wanted to check and see with the chat over on Discord that we have sound and that we have video. So I'm going to head on over there for a moment. And, oh, you can see there's a preview from the blog post about the project. And, yeah, Brian, thank you so much. I got the yup from Brian. And let me know where you're watching. Are you on YouTube, Twitch, Periscope, etc.? Facebook? Anyone on Facebook? All right, good. So I'm going to head over to the bench, and I'm going to check out my chat over there. I've got an iPad set up with the YouTube chat as well, because we do still tend to have people hanging out in both chats. So bear with me for a moment as I attempt to get that chat up. Northern Pike, all right, you are on YouTube and Discord. That is excellent. And if you'll bear with me, I'm going to try to find the live stream on my iPad. Oh boy, it's not refreshing super fast. Oh, error loading. Okay, I'll try that again later. So I'll primarily be in the Discord chat for now, unless I'm able to successfully come over here and find the live stream, which I'm not. All right. Now, John, use full width of the video. Ooh, I've got sound on here. Are you not seeing full width of the video, Yanisku? I'm not sure. Let me know. Take a screenshot if you're seeing something weird, because I'd like to know. I am, as far as my, let's see, as far as my broadcast goes, I'm capturing at a full widescreen 16:9, and that's what Wirecast is broadcasting at. Oh, all right. Here's the YouTube, and I'm going to pop open the chat. Easier said than done on the iPad app. Let's see if I click the video. Shoe fly. And then the trick is always, can I get to the YouTube chat without watching myself on like a 10-second delay? I did it last time. Where is that chat? Whoa. Live chat. There it is. Hey, there you're all there. Hello. Okay, so thanks for tuning in. And without further ado, the project this week is the Screaming Cauldron. So let me give you a quick demo of this. I don't have any candy in here right now, but we will get it built, rebuilt actually from scratch, and we'll put some candy in there and demo it. But for right now, I'm just going to turn, unceremoniously, I'm going to turn on the, oh, there we go. So that's the boot up. I just have it set to scream once when I boot it up. And this is, let's see, yeah, you can even see the colors in there. I'm going to just wrap. I put some diffusing tissue paper in here that makes it look a little nicer, and also you should be able to see the effect a little better on camera.
The battery is...
Oh, what just yelled at me? Huh. I have an Amazon tap over there that just yelled at me that the battery is low. That's informative. All right. Is that helping on camera or not? Oh, you might be able to see it. Yeah, you know what? Here on camera, in real life, it looks a little better with the diffusing paper, but there you can see it better this way. So what I've got is a proximity sensor. Can you see that on camera right now? Oh, I just hidden it. Nope, just hidden it. So if you see inside of there, we'll take a closer look at these things in a moment. I have a little distance sensor, and if you watch the LEDs, they're changing color as I get closer. And so they're going green in sort of their normal state, and then they're going towards yellow and orange. And that's what happens when you actually reach in fully to grab candy, is that we're going to scream. Now, on the real project in a second, we'll do is set it up with multiple sounds so you don't have the same sound over and over again, because that'll drive you crazy. But the idea for this is either you're handing out the candy at Halloween, or you're setting your bowl out on your porch and you're off trick-or-treating, but people are coming and taking candy. So it's an interactive kind of fun experience you can have to spook people out. It'll probably scare the first person a lot. So that is the project. That's the Screaming Cauldron. And now let's take a look at how this is built. So I'm going to turn it off. And let's start actually with a little demo. I'm going to switch over to this camera. A little demo here of the proximity sensor. So you can see here, this is a infrared proximity sensor. And the way this works is that it has a pair of, well, it has a bulb, an infrared bulb that's sending out a light, infrared light, and then it has a sensor that's receiving the infrared light. So based on the reflected light bouncing off of an object, the sensor sees more or less infrared light. And it runs off of 5 volts, so it has 3 wires here. We have the red and a ground running to 5 volts just on a power supply. And then this yellow wire and ground I have connected up to this multimeter so that I can measure the DC voltage coming off of here. So you can see when it's pointing kind of far off into the distance, we get 0.025 roughly volts. And now I just broke that beam by placing my hand out here. And this is actually a different one than the one I'm using in the project. At Adafruit in the store, we sell 3 different infrared sensors that are kind of tuned for different ranges. This is the medium range one. And you'll have to check, maybe someone could put a link in the Discord chat, in the YouTube chat, what those distances are. I forget. I don't think I have it written down. Oh, this one I do. So 20 centimeters to 150 centimeters. That's the range. So here it's reading about, it was at about a half a volt. That's probably at that 120 centimeter mark. And then as I bring my hand in closer, we're getting up towards, it'll max at about 3 volts. Yep, 2.7. Okay, so that's how this sensor works. And the way we use it in the project is that I have a microcontroller. In this case, we'll be using the Trinket M0. And the microcontroller is reading on one of its analog pins the voltage coming from that infrared sensor. So when that voltage goes beyond a certain threshold, will trigger that scream. And the way the lights work is they're actually constantly checking that same pin's voltage and adjusting the color of the Neopixels based on that changing analog signal. So I'm just going to check the chat real quick and see if everything is copacetic. Northern Pike asks about using wax paper. Yeah, anything that'll let some light through that can be a little distance away from the individual LEDs will tend to diffuse the light, which is nice. My daughter actually made the suggestion yesterday that I get dry ice, which would be really cool to have this sort of fogging. Excuse me. And that same effect, if you have some wisps of that dry ice sublimating into the air, it will diffuse and scatter the color coming off of the LEDs and give you a really cool effect. So let's see. Good, good. Yeah. Okay, audio sample source. Someone asked me, oh, Noam Pedro asked if anyone knows the sample source, if you know where that came from. I actually don't know where it came from originally, other than that I found it online in a public domain usage web repository of sound clips. So there's, I think, freesample.org and some others that you can go and check out. And one second, I want to turn down, I'm hearing some feedback from the headphones over here. I think that'll fix that. Hopefully you weren't hearing feedback too, but I don't think so. I think those were just monitoring there. Okay, so let's move on to building the thing. So I'm going to take this demo away and clear some space, and I can turn off that bench power supply. That's kind of a loud fan. in it. So, that's nice. Okay, so let me take the existing cauldron apart so that you can see its bits and pieces. And I'm going to disconnect some parts here as I show you what we have. So this is just a battery, LiPo battery, and one of our power boosts, and that's because I'm running some powered speakers in here that are meant to run off of USB. So I needed a USB power supply, and that's what I chose. This is a little 3D printed case I made a while ago for traveling. So that's essentially a phone charger. If you have any USB phone charger to plug into these powered speakers, that would work. Or another nice option would be any kind of rechargeable speaker that has an input. This is a Bluetooth speaker, but you can plug this audio in and that will go directly to our audio effects board, and this has a battery inside, which is kind of nice. I have a couple of these. Here's one I got from DigiKey at one point, a Maker IO DigiKey little powered speaker. So something like that works great. But I'll show you the ones I'm using are these. Unplug them. And one thing I'll show you here, one of the main reasons we're rebuilding this on the show today is that I built it on a breadboard for the original build just to test it out, but I hate trying to leave a breadboarded project in real use because the wires always just want to fall out, and it's difficult to actually troubleshoot the thing in the heat of the moment when it's all breadboarded. So we're going to actually solder it onto a Perma Protoboard today. So these are the speakers I'm using. And these are these nice little inexpensive USB powered speakers. So they have a little amplifier built in, so we can go line level into this audio input, and that will allow the sounds to be heard coming off our audio effects board. And then I have the breadboard, aforementioned breadboard. And I just have a panel mount USB extension on there that was just making it easier for me to program it when I was working on it, but I don't think we'll leave that in the final design. We'll see. And so here's power, here's our audio effects board, here's our trinket, and what I'm using to power these and the Neopixels is 4 AA rechargeable batteries, and it's important here to use rechargeables because alkaline have a bit higher voltage, and so they'll be a little too high of a voltage for the Neopixels, which want to be run at 5 volts. So by using rechargeables, you won't risk damaging anything by going above that 5 volt mark. And in here I have the IR sensor and a bit of gaffer's tape, my favorite. So a little IR sensor. It's a little smaller than that one I think I was showing. The different sizes correlate to the different distances that they measure. And then inside of here, I'll pull this out and we'll reinsert it later. I have 1 meter of these 30 Neopixel per meter strips. Get this cauldron out of the way. That's one of those fun things you get to say around Halloween time. Let me get this cauldron out of the way. So here's a meter of that Neopixel strip. That happens to fit just a little more than we need even on the inside of that rim. So if you were using a smaller bowl, you could get away with cutting this and then reusing the second half of it somewhere else. These can be cut at between every Neopixel, so you can solder wires onto there and use them for another project. Okay, so that's the sort of foundation of things, and you can see here I'm struggling with keeping everything from pulling out. So the next step is going to be to rebuild this circuit onto a Perma Protoboard, and I'll talk about some of the steps along the way, and then if we have time we'll talk about programming it. Let me check if there's any questions inside of the chat before we get started on soldering that, and I'm also going to go over here for some delicious iced coffee. Let's see. Thank you, Yonisku, saying I have good video and audio today and all setups. It was weird when I loaded Wirecast. Wirecast is the program that I'm using, most of us at Adafruit are using for live broadcast. The setup from my last one, the Clockwork Goggles, was showing a sort of square aspect ratio video cropped in. It wasn't stretched inside of here. I don't think that's what got broadcast, but something funny happened. In fact, this program crashes every time I quit it. I save my file, I quit, and it crashes. So I think weird things could be happening. Northern Pike, great idea. Your daughter's very smart. Yeah, she's very crafty and very creative. She's also very conscientious because she said you might not want to actually do dry ice because then someone could hurt themselves if they were reaching into the bowl and grabbed that instead of candy, which is a good point. It can kind of burn your skin, sort of freezer burn or frostbite kind of burn your skin. Yeah, so the speakers could fit with 3D printing cover for them. Yeah, absolutely. You know, this could be a really cool project to build a little more custom. So 3D print the bowl itself with integrated electronics into it. You could take it to a really high level of finish. I didn't have time, frankly, so I wanted to just reuse something that I had, which was this cauldron. Okay, so let's head over and start putting this thing together. So what I've done is, in advance, I have prepped the Perma Protoboard. So that's what I'm going to be using instead of this breadboard. And really the only preparation necessary for this half-size one is to tie the ground rails from both sides of the board to each other and the power rails from both sides of the board to each other. With the longer ones, you also sometimes need to bridge across halves, at least with the breadboard. I don't think you do with the Perma Protos. And I'm going to grab a little pan of ice so that I can hold things a little closer to the camera. Let me know if that goes out of focus. I'm not sure what the threshold is exactly. Okay, so first thing I'm going to do here is take off this power supply, and let's just set this here for a second to show you what I've got as I actually I'll leave most of this intact and then rebuild. This is something I like to do. If you have the parts necessary, and I do have a duplicate audio effects board and trinket, it's nice to leave the breadboarded one in place as you build the Perma Proto one so that you have a reference. I also have a Fritzing diagram. Actually, I'm going to switch to that over here for a second, and that will allow you to see, and me to see, what this looks like. Let's see. I can just pull that over here. Whoops, it's too big to fit on that monitor. Hold on. Stand by. Okay, that sort of fit. And let me... Okay, I'm going to stay zoomed in. You get the idea with this battery pack here. That's the diagram. I'll actually leave that up as I go over there so I can look up at that as I work. But let's talk about it for a second. So what we have, I won't follow this exactly because I think I'll probably place the capacitor right directly on the rails, but you can't rotate a small arbitrary amount inside of Fritzing, so I decided to diagram it like this. But so I have the trinket tied to ground and power. I have the audio effects board tied to ground and power. I have the IR sensor running to ground and power, and then its output is going to this pin 1, D1, which is also, I think, analog 0, confusingly, on the trinket. So that's where we're going to be measuring. The pin D2 is going to be sending a signal from the trinket over to the audio effects board. So the audio effects board, if you're not familiar with it, this thing is great. It actually is a very simple way to trigger sounds without necessarily needing a microcontroller. I'm using one in this case because I wanted to do something a little fancy with the Neopixels, but you could actually build this project without. You would just need to invert, with a transistor, you would invert the voltage coming from your infrared sensor so that it doesn't trigger constantly and then untrigger when you get close. It would need to reverse how it works, but I tested it and it will work well. But in this case, we're sending an output on our digital pin 2 which sends voltage to this pin 0 on the audio effects board. The audio effects board, you can actually tie ground to any of these 10 pins, I think, yeah, these 10 pins, and have different sound effects or sound effects banks on them. If you want to know more about it, check out the Chewbacca project I made more than a year ago, the Happy Chewbacca mask. There I used it in sort of this simpler mode where there's just a switch and a dial to go choosing the different banks. And then I have nextly, this Neopixel Strip, which is again tied to ground and power, which sometimes you want to have a separate power source for your Neopixels versus for your microcontroller in case you're drawing a lot of current and there's dips in the current and you reset your microcontroller. That can be a problem. I found with these 30 Neopixels, and I'm never lighting R, G, and B at the same time. So you're drawing essentially a third of the current max if you go all red but don't turn on green and blue. If you do red, green, and blue, then you're drawing the full current. So yeah, in this case, I'm keeping it simple and getting away with a single battery pack. And I am using this capacitor, which does help smooth out any dips in voltage that can occur in the system, as recommended by Phil B. in his Neopixel guide. I try to nearly always follow that procedure of having this big fat capacitor, as well as this 470 ohm resistor between the digital pin output that is on the trinket that's talking to the digital input on the Neopixels. So that's our circuit. I'm going to set that there so I can see it, and then I'm going to go build it. How are we doing on time? We have 40 minutes. I think that's enough time to get this thing going. What do you think? Yeah, Northern Pike. Yeah, you absolutely. The question is, what is the Perma Protoboard? This is a PCB that, oh, let me move this up so you can see better, sorry. This is a PCB that mimics the same connections that are found on the inside of a breadboard. So we have these columns that are all tied to each other on this half of the board. So if I go over to row 4 here, for example, let me get something to point with. Row 4 is tied, this column 4 is tied on J, I, H, G, and F. Okay, so just like a breadboard. So yeah, you solder to the bottom side of it just like you would a PCB, but you don't have to do as much manual connecting of wires because we have those connections in place. I love them. They're great. And because they mimic the breadboard, they're a really nice step if you just want to mentally go directly from here's exactly where I had things connected on my breadboard. I'm just going to make a permanent version of that. So that's what that's about. Okay, so let's get going. First thing I'm going to do is solder in this capacitor, and I have an extra so I don't have to take that guy apart like I said. So capacitor, I'm going to set the striped negative side on the negative rail here. Before I solder a couple of these things in, I will drop my parts in place just so I make sure everything is going to fit. The idea I had here is actually to separate these two boards from each other as much as I can because I need some room to plug in a USB cable if I'm reprogramming the audio effects board. And I realized I didn't explain this very well. The audio effects board, the way you work with it, let's switch cameras for a moment. Check this out. Audio effects board's super awesome because it just shows up as a USB drive when you plug it into a computer. You drag WAV files onto it or OGG Vorbis files onto it. This one has 2 megabytes of space. You can also get one that has 16 megabytes of space. So these sound files, I made them mono and pretty small. They're pretty short and lower sample rate, 16-bit WAV files. So you just drag them on your computer, eject this, take it out, and then when you touch the trigger pin to ground, in fact, let me demo that. What am I doing? Let's not solder yet. Let's demo stuff. You will hear the sound effects. So I plug the output of the board to this little speaker, and I'll power the speaker on. And then I will just take a jumper cable. Where's one? Here's a nice jumper cable. And what I'm going to, let me switch cameras again, sorry. What I'm going to jumper here is pin 0. Oh, I need to power this as well. Let me power it. I will jumper pin 0 to ground, and that tells the board to play a sound file. The super clever thing about this is that you don't just play a single sound file per pin. If you want, through naming convention, you can set it up so that you have multiple sound files that can be played per pin, and they can be named either T00, which means stuff that's played off of the 0 pin. T01 would be stuff that's played off of the 1 pin, and so on up through 9, which takes care of our 10 pins indexed at 0. T00.wave would be the only thing that plays when we touch that pin 0 to ground. If you name it T00 next 0 or 1, I can't remember which one it starts on. I think it's also indexed at 0, let's say it is. So T00 next 0.wave, T00 next 1.wave, and on through to 9. Those would all be played on pin 0 subsequently. So it's just like a track order on an album. It would just play 1, 2, 3, 4, and 5. There's also rand instead of the word next. If you use the word rand, then it will randomly pick between those 9. So check out the just general guide on learning on Adafruit for the audio effects board to find out more. But it's a super clever way to get around the fact that you don't need to program the thing, but you can get some slightly more advanced behavior out of it. And there's even a latching and a non-latching, so it will loop a sound continuously until you remove the ground, or there's one that will, I think, loop continuously when you touch it once and then stop looping when you touch it a second time. All right, so let's check this out. I'm going to put on some glasses. Where are my reading glasses? I can't see this thing. Pardon me for a second. By the way, this is pretty cool. When I was in New York for Maker Faire, my friend Doug North gave me this. Check this out. This is, can you see this? This is a little magnifier that clips to your glasses. Doug is a watch and clock repairman, and he builds automata. So now I have, how cool is that? So here I can see stuff that's right there. Lets you focus like about 2 inches from your eyeball, which is pretty great. I don't need it in this case, but I wanted to show you that because I'm very happy about that. I kind of want to get a second one matched so that I can have stereo vision, because it's hard to solder and do things with just one eye open. And if you leave one open and one closed, one is blurry and you lose your mind. So, okay, so here is the demo. So I'm holding one end to ground here, and I already soldered pins into this, so I don't have holes to poke it in. All right. All right, so there's one now. Check it out. Zombie sound. Weird growling sound. And a crow. So I love that crow sound. It's a little anticlimactic after the other ones, but what do you want? Okay, so that's a little bit on the audio effects board. Any questions about that? So someone asked, is it monophonic? Yeah, it can be stereo. It'll output stereo. And even though I have 2 speakers, I have, with these sounds and the fact that they're coming out of a small space, I decided to make them mono, which makes the file size smaller by about half. So I can unplug power from that. I can unplug this speaker. I'll turn this off. Thanks, speaker. Thank you, DigiKey, for that speaker. And let's get to the board here. So yeah, my plan was this. This arrangement allows me to get as much space as possible there for plugging in a USB cable later if I need to change those sounds out, because that's how that works. And I can see I probably should leave that in there as I solder it, so that, or at least have a strategy for getting that further up. Fit it around this board. No, that's as far as over as that'll go. Yeah, so something like that will be good. So let's solder this one in place first, and the capacitor as our starting point, because we need a little strategy. I'm also gonna have to dig around and find my blue tack because I have run out of the clumps that I had sitting here. And I have some inside of my, let me go get some. Hold on one second because I want to be able to, how can I make you stay? I can't, that's going to fall out. All right, hold on one second. And I'm going on a mission. Any kind of little putty or clay will work for holding these guys in. And I don't think I've run out, but I think I have not left mine where I think it was. All right, I need to go to a backup strategy, which is going to be a little bit of tape. How about, all right, let's do some Scotch tape, that'll work. Okay, place that there. I just need it to not fall. There we go. All right, I'm going to try to make some quick work of this soldering. Put that back into camera view. Where is some solder? There it is. Yeah, people ask, I use that versus a sponge. And these are a bit long. I can clip these if we have time. Oops. Good idea to clean your tip frequently or between every joint that you solder. So you can see here, this is soldering these not only to the board, but to each pin is on its own row there with sharing with 5 other pins. So that's what we can solder jumper wires to that will connect the parts. Okay. Looks good, and I will trim the leads on here and here. Yeah, sockets. Someone mentioned using sockets. That's a fun way to do it too with these. You solder in sockets, and then you can take parts in and out. These are not super expensive parts, so I probably wouldn't try to reuse that in another project, so I will go ahead and leave that on there. That would be maybe a good way to do the audio effects board so that it's easier to lift up and program. But I don't want to take the time right now. But especially like the really low profile headers, if you use those low profile male and female headers, we sell them for feather stuff, but you can use them for anything. Those are super cool. All right, so let's set that about there and tape that in place. And I'll just keep an eye on that as I solder. Sometimes what I'll do here is just solder one pin in place to kind of tack it, and then I can heat and move that if I need to adjust things. All right, which is what I'll do in this case because I don't have 3 hands. So I'm just going to solder one point up here. Then I'll heat that as I adjust the placement of everything. And then just let it cool. That's pretty good. Let's test that. So you can see it's up off the board enough to take that in and out. That'll do. And let's just tack the other side and do the same thing. So heating it, I'm wiggling it a little bit, letting it cool, and we're good. All right, I think that's great. Let's solder the wrist. So I'm pulling this end down because it kind of wanted to ramp up. Let that cool. All right, cue soldering montage music. So, you know what would have been a great idea is to pre-solder sockets so that you didn't actually have to witness all this soldering if you didn't want. But those of you who are fans of watching soldering, then this is dedicated to you. Going out to all my soldering fans. You know who you are. One challenge of this project has been trying to not eat all the Halloween candy, because that is the Halloween candy that we're giving out. We got it in advance. We were planning well. And then I realized I wanted to work on this project, and I said to my wife, hey, mind if I use that candy for some photos? She said, sure, but don't eat it all. Sometimes I can't remember which things I've mentioned publicly or not, but I think I made mention yesterday somewhere publicly that I tend to eat only the clear gummy bears. In fact, that's the only thing I've eaten out of the whole pile of candy that we have. Is I opened up a bag of gummy bears and I ate the one clear gummy bear out of there. I think it's pineapple flavor, maybe. I like clear. Same with Lifesavers. I like clear flavor. All right. The tape comes off. And now we'll be able to plug that in. So we just got multi-height board action going there. And that's all looking correct. So let's see what's next. Okay, so I've got a resistor that I'm using. This is this 470 ohm resistor. Thanks for soldering for us. You are welcome. Yeah, wire wrapping. So what I'm running is from pin 0 over to an empty space. So I've got this little empty space here. So I'm going to bend this into place and about right there. That is on row 7. Is that what I did on my diagram? I can't see it well enough to know, but maybe that's where I did it on that diagram. It won't match up exactly, but very close. So you can see here, resistor from pin 0. Let me just double check that. Yes. Doug, my clock repair buddy, automata builder buddy, he said that he recommends an optivisor, which is that big visor. It flips down and it's got it's stereo. It's got 2 lenses that you can get them in different magnifications. So I'm thinking about an optivisor. I think some of them might have integrated lights. Anyone here have favorite magnifiers they use for their work? Let me know. Because as I'm getting older, I don't have the bionic vision of my youth. Okay, so there's our pin that this is where the Neopixels will go. And again, it would be great to put connectors on here so you can plug and unplug. I'm not going to do that with this project. I'm just going to solder everything pretty much directly to the board so that we save time and make it easy. But yes, there's definitely benefits to doing it the other way. Okay, next up, you know what I may do is I start cannibalizing stuff from this board just so you don't have to watch me cut jumpers, because I kind of cut these to size. So I'm going to steal these. So I'm going to take out ground for, this is the audio effects board. So there's the ground. So you want to come through, come here. So audio effects board to ground. I'm very good at accidentally saying ground and then plugging into power rail. That's a really good way to create the blue smoke. I do it more than I Wish I did. But that's what happens usually when you're working too quickly or late at night. So I will double check this. It's really good to double check that kind of stuff before plugging it in. Okay. So that takes care of ground. And now let's take care of the power. Same thing. Steal that from this breadboard. And that will go. So this is the V in, which on the audio effects board, I think it'll run off of maybe like 3.3 to 5, anywhere in that range, or maybe even 6. I can't remember, so check the specs, but I know it's meant to run off of the 5 volts of USB, so that's what we're delivering it via those batteries, is just about exactly 5 volts. You could also make a version of this that plugs into a DC wall socket with an adapter. How am I doing on time? We have 20 minutes, 19 minutes. Can it be done? I think it can. I should talk less and solder more, but then how much fun would that be for you? Okay, so 5 volts of VIN, awesome. I've already tied across there. Let's do, oh, that's a ridiculous, I'm going to cut one of these when I make it small. So this is going to be battery pin on the trinket to the power rail there. And the jumper that I had made for ground over on my breadboard was ridiculously long, so I'm going to cut that. So in case you were worried when I said I was going to reuse jumpers that there would be no wire stripping action, turns out I lied. There will be wire stripping action. And that'll be, sure, I'll steal this one. It's half stripped already. So that just needs to be about that long, so I'm going to clip it, strip it. These auto strippers work well, especially on thicker gauge wires. Not so well on the 30 gauge tiny little silicone ones I used last week. So ground to ground at a reasonable length. That's better. Solder, solder. Clip, clip. All right, what's next? All right, now we just have connections to the off-board stuff and the connection between these two. So let's do that one first. So I'm going to take, and I'll keep consistent with, let's switch cameras just for some variety for a second. I will try to keep consistent between the diagram that I've put together on Fritzing, especially because I'm sharing these, and what I do here, so the photographs match. So I'm going to go for a yellow solid core wire. Where'd that wire go? Why would I hide that from myself? A big box, here it is. So I'll take a piece of wire, and that's got to be like, strip one end, put it where it's going to go, and then see how long to make the other side. Boop. Where's this going? This is from D1. That's not D1. D1 snaking over here to 0, which is about there. So I'll clip it there a little longer and strip it. This is a pretty unpopulated board, so you don't have too much danger of wires crossing over each other and shorting, so you don't have to be as precise in your insulation stripping procedure. All right, so I'll go from there to 0. Whoop. That looks good. Scream at me in the thing if you see in the comments if you see me do any Like, hey, you just said ground, and that's not where you soldered that in. I'd love to have you be a second set of eyes to avoid calamity. And what are people going to dress up for Halloween? It'd be a fun topic for the chat. I don't know what I'm going to do yet. I may try to do a steampunk thing to match, to go along with what my daughter decided to do. We'll see. It's kind of a fun one. I went as Mr. Robot last year, I think, or the year before. Right, so we're good there. Okay, so now we have our sensor. Plug him. So he's going to go. Oh, I already unplugged him from there. So this sensor is going to power and ground, and then into, what did I say? 2? Analog 2. Did I screw this up? Did I? Oh, let me double check. Well, you don't know what I had said I was going to do before, do you? Because I posted it pretty quickly. Ah, yeah. Yellow was supposed to go to 2, and white was supposed to go to 1. And you know what? I'm going to fix that rather than, I could fix it in code, but I want to take pictures of this one for the guide, so I'd like it to look correct. So that's a nice aspect of having a piece of wire that was a little long, is that I can probably get away with just snipping this here, stripping it. I don't know. Oh, yeah. So white, that's the color that was coming off of this thing already. Normally I wouldn't use white. It's really hard to see on the screen over there. I like blue or green. Those are good. All right, so now this is in D2 of the trinket. And we can still make it. Yes, and we're not shorting that resistor. So that's an easy fix. The code for this, oh, where is that now? I've lost it. Where are you, thing? There you are. The code for this, I wrote it in CircuitPython for the Trinket M0, and I have variables up at the top of the code that determine which pins are being used for what. They're all pretty much interchangeable in this case, I think. They can all act as an analog, they can all act as digital. So in the code, you could decide which one's the Neopixel, which one's the IR sensor, and which one is the, what's the other one? The sound running out to the audio effects port. Okay, so now let's take our sensor wire. Oh yeah, I have 2 of these sensors out here. Okay, so let's take the sensor and let me neaten these cables up. Okay, I'm just going to go right here. Keep them all together. That'll be nice and neat. So we'll go ground, power, and there for the pin 1. This I really wish I had some of my blue tack. Where did I put it? Maybe it is still sitting over here somewhere. No. Yeah, tape may or may not work in this case. Blue tack would be much nicer. You know what I mean when I say blue tack? It's also called poster putty. No and Pedro are the world's foremost proponents of blue tack. They use it to great effect in lots of their builds. So watch their various builds to see some real blue tack pros. They would never be caught without it, like I have here, I suspect. Okay, and I'm going to double check those, but that should be power, that should be ground, and this is D1, right? Trim those. Clip, 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 get rid of the tape. Yes, ground to ground, power to power. All right, so this sensor actually has a little JST connector on the end, which is cool. We could actually probably extend that if we had to. I have some extension cables, which I was thinking of using for the battery. Is that the right kind? No, this is not at all the right kind. These are these are 2-wire, not 3-wire. But you could get a 3-wire extension, I think, if you wanted to keep that modular and make it longer. So battery, right? Is that okay? So I got the Neopixels. I got the battery. Let's do the battery. So question mark here. Here's the new one, the fresh one. I guess I can reuse this one. So switching cameras. So battery pack is a little on the short side, especially because we might want to take it out to change batteries, and it has the on-off switch on it. So I could take a moment here to solder it to a JST extension, or this JST extender, just trim its ends off and solder to the board, solder to the battery pack, and it gives us a little on-off switch in the middle. So I think for time's sake, we got 10 minutes. I won't do that, but that's what I would probably recommend. And I'll probably put it in the guide that way. I may rebuild this piece for the guide. So just out of sake of time, I'm going to solder these little leads directly to the board. But it wouldn't be a bad idea to give yourself a little extra wire length. This is kind of a set it and forget it thing. You'll probably just turn it on at the beginning of your trick-or-treating night. Same with turn on the power to your speaker if it has that separate power. So I don't think I'll be needing that button a lot, but you could certainly make that easier to access if you wanted to. And so here we go, ground to ground. I have that off, by the way, before you solder these batteries in. I would leave that off. Also gives us another chance to triple check that I've soldered those to the correct spot. I think most of the things I have plugged into here have diode protection, but that looks good, right? Red to plus, 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 black ground, black ground, black ground, black ground, black ground, black ground. That's looking very good. Okay, scream at me if you see something wrong. No one's screaming. All right. Do the right way, as you said, so you have two power switches. Yeah, two power switches. That would make it easier because you would have that clicker up there. Thank you, John Shaftstall. I would recommend that. I'm just going to skip it so that you don't have to watch me splice some wires together with solder. And we got power. You know, it's worth a test right here, right now, before I plug in the Neopixels. So I'm going to power it up. And that's a good sign. So we have a power LED on the audio effects board. We have a power LED on the Trinket board. The Trinket board, let's see. Oh, shoot. I did screw up, darn it. I really have a hard time with this yellow. Hope I didn't ruin anything. I don't think I did, but I just ran 3 volt. Yeah, that won't hurt anything, but I just ran the 3 volt, not the, this wire is now going to be out of length. This yellow wire is the bane of my existence. Let me switch cameras. Yeah, this yellow wire, I thought I had run to the D2. I actually ran it to the 3 volt. So now I've split the difference between all possible positions. And there's going to be a little bit of desoldering here. This is real. This is how it, as real as it gets. All right, so that I've removed. I'm going to get a nice new length of the yellow wire, strip it. I'm actually going to just heat that pad and shove it in. Okay. And let's see, this has got to go into D2. Man, oh man. I like to say that this happens more often when you're doing it live because you're a little distracted, but that would be a lie. I do this anyway. Not careful enough because I'm so excited about the actual project. Okay, there we are. Now we're in pin 2. D2 on the Trinket. That's where we need to be. The reason I thought something was up, by the way, is the Neopixel, or the dot star built onto the Trinket, was turning colors, which I believe that's what it does under the normal conditions of the software I've put on there. I'm just going to double check that's the one I shoved through. And here's this one now in, with any luck, the right spot. spot. I can trim you. Okay, so that is now confirmed D2. That's the row for D2, D1, D0. Let's try it again. Yeah, okay, that going green. Actually, I don't know why that's going. So, oh, I know. One thing that it's doing is as that distance is changing. Okay, so what we'll do right now, I'm actually, before we do the Neopixels, I want to plug this into the computer, and we can actually use the REPL to diagnose what's going on here. So let's switch over here. And I'm going to open up a screen session. Oh, 5 minutes. Are we going to make it? Are we going to make it? So I'm going to plug the trinket in, and I'll also turn on power, because that's what powers our little friend, the IR sensor. Okay, and then, so you can see here in this session, let me make the text big. Google, why is that Google Drive thing bothering me? Okay, so I want to tell this to do a screen session on, yeah, I have 2 trinkets plugged in. I wonder which one. Not that one, darn it. All right. Just for a second, I'm going to unplug my little switcher that I use. That's also a trinket running CircuitPython. So here's the cheap and easy, dirty way to figure out which one switches only have one. There we go. Okay. So that is telling me the voltage that's coming off of the IR sensor. And is that changing? Whoa, what happened? Let's look at the program. And also let's make sure that that is showing up as so here's my editor. Is this right? Yeah. Okay, so that's what's running on there right now. And something appears to be up, because that screen session shows me that it's not reading the sensor. It's just giving me the same voltage value. So let me double check in the code where I'm reading that. I had changed this around as I was testing stuff, so I might have done made an error in the code. So let's see. I've got the audio effects board is out to pin 2, and that's what I did, yes. The analog in is on D1, and that is also correct. And then the Neopixel is D0. Oh, this all looks correct. And I'm printing that print statement doesn't look at all like what I expect. Let's change it here and save. So this is, hopefully this will be a good demo of CircuitPython in action. Oh, stop doing that thing. As I will tell, how about it to, oh yeah, look, it just quit the screen session. Something funny's going on. I wonder if I hope I didn't zorch this little board when I did what I did. There's a chance that incorrect solder I did hurt something. You know what? Let's since I have to do this anyway, I'm gonna go and solder in the Neopixels just in case it's like freaking out because it's not finding them. That seems unlikely, but I'm gonna do that anyway, and that may help with diagnosing it. So that D0 goes to this resistor. Here's my Neopixels. So they're going to go to power, to ground. These are going to be tricky without blue tack. Let me just do those two first. And I also just have a look around here and make sure there are not any obvious shorts. Because some reason it's reporting no change. Did that fall out? I hope not. Let's see, wire, are you still there? Yeah, it fell out. It's okay, I have plenty of ground or power rail to choose from. Stay. Okay, so now we will place our D in for the Neopixel at the resistor. Don't fall out, please. I'll hold that wire to prevent gravity from, oops. Famous last words. All right, Gnome Pedro, send blue tack. I did tin these wires so that it at least has a little bit of stiffness to it. When I bend it over there, it stays. Okay. And let's look let's trim these. Our little friend, the IR sensor, is here. Yeah, there's no short there. There's no short that I see anywhere. All right, is anyone yelling out a solution? Is the resistor used? Yeah, it wasn't. You're right. Plug the speaker in, yes, no. Yeah, I can do that too. What I was looking for is actually, so in the software I have it turn on the red LED on the trinket. That's the way I know that I've reached the threshold on the board. So I'm gonna plug this in. Let's turn on power first, actually. Yeah, look, bad sign. So I don't have Neopixels lit. I have done something wrong. Okay, what I'm going to do is, let's see, if I wrap these over my shoulders, you'll see if they light up. So this is, yes, someone said this is real time. This is live debugging in action. So we can go back to, thank you. So print. Okay, I'm going to reopen this code from my repository. You can save, is it living there? No. It is in, I have it in my Dropbox actually. And this is Screaming Cauldron. I'm going to open this one and I'm going to save it as to overwrite whatever's on the board. So there's the CircuitPython, namepi save. Replace that, and then I'm also, oh, how about that? It's working. Oh, you know what happened before? I didn't have this code on that trinket. Yeah, okay. So now we should, I don't know what code was running on there. That was weird. I screwed that up. All right, let's make a new window here, screen into it. Oh, it's changed its USB name from before. Okay, so now what you should see, let me find the camera. What you should see is I have that analog value going up as I get closer. And then below it, I'm just listing some color values of what I'm running on the board for red and green. Okay, so now that works, let me switch out to the other camera and let's plug it into the speaker because I think we're close to having it work. Yeah, whoops. You know what? I fooled myself because I had pre-programmed the audio effects board, but I had not pre-programmed this trinket. That was a trinket new out of the bag, so it was not going to just magically know what to do, despite how much I wanted it to. Let's get the sensor over here. Let's plug in. I'll use our speakers that we're going to use in the project. I bet we're over on time, aren't we? Oh, we're 5 minutes over. Okay, we'll rush. If you can all hang out a few more minutes, we're super close. So let's plug in speaker power. Let's turn on. Okay, so that's the one that happens when I boot it up. And let's see. Oh, I didn't. Sorry. I didn't switch cameras because I unplugged my little camera switcher. I got used to that working. All right, camera switcher. And, whoops. Can you still hear me? Yes, okay. I thought I just unplugged my mic pack. Okay, so you can see now I've got the color changing on these, and you'll see a red light go on the trinket, which I do when we break the threshold of, there we go. And there you can see the colors of the Neopixels are changing. Let me turn the volume down. This actually has a volume knob on it. The colors of the Neopixels are changing as I get closer. I'm essentially mixing out green and mixing in red. Okay, and so last thing we'll do is unceremoniously dump this into the cauldron and hook it up. So let me switch cameras. I like how I'm holding things in my mouth to get it done. So I'm going to put the guts in here, and now they're not going to all, they're not delicate like they were before with all of the breadboard. I'll take our distance sensor and I'm going to gaff tape it right here. And we're just going to listen to zombies as we do this. And so the way I'm using it is the sensor is just running across the top of the rim, so it'll notice a hand coming in as it hits its field of view. You could also probably run it from the bottom up if you had some way to clear out the candy using a little tube or something like that. But this seemed to work pretty well for me, is I'm just taping that in there. Get a little extra piece. I'll put our speakers inside. And again, for our usage, I'm okay with it just being left sitting there. I'm going to cover it with something, and I'm not even taping that stuff down. So Neopixels, I'm just shoving up inside of this little, there happens to be a convenient plastic rim. You may want to punch holes through and use zip ties or something like that. Mine will probably fall out a little bit here as we work on it. Whoop, go behind the sensor a little bit, and maybe we can just get it to tuck in well enough for right now, but the way I had it running before, I just ran a few little strips of gaff tape. Actually, let's do that. So I'm just going to make skinny strips by splitting them. This is a good gaff tape trick. You can really easily make 3 out of 1. If you've ever worked in theater or film or TV, you know that there's not too much you can't fix with gaff tape. All right, so that's in place. And then the last thing I'm going to do is actually have some black tissue paper, and I'm just using that to cover the guts, but we still detect when a hand comes in. And then I can pour candy in. And I may need to lift the sensor up because I think it's looking at the candy a little bit. So sorry we didn't have enough time to look at the code, but I'm going to be posting a guide to this in the next few days. And that'll give you all the details. There we go. Ooh, there's a good position for this. Let me show you what I just... Oh, sorry. Right there. That's a pretty good position. If you, by the way, when you see this green, it means it's not detecting something. So it's a way to know that we are not actually within the threshold yet. So now as you can see it goes yellow. Oh, and I think, you know what, this version of the code I saved on here is not my final, and I have a delay. I have like a 3-second delay after each hit, so it's not going to do it over and over again. So that's also another reason, at least while I was developing it, that it was convenient to have a USB cable running out of it, or a little panel mount cable, so that we can tune the code without having to dig out the guts from the candy. And now it's just decided to cycle over and over again, so I think my sensor is looking at something it shouldn't. Let me lift him up and out for a second. Maybe. Yeah, flipping out. No, it's flipping out for sure. All right. This goes back to the conversation about there might be a good reason to have the power switches available without digging through here. So I'm not sure how I got it stuck into that loop, but I'll investigate that further, and I hope you enjoyed the build today. That's the real stuff right there when we have those kind of shenanigans going on. So C. Grover said, test the sensor with voltmeter while powered on. Yeah, it's a good idea to check that out too. And also when I have it plugged into USB, I'm checking its voltage just with that little print statement in the code in the REPL. So yeah, thanks everyone for tuning in. Sorry we went a few minutes over today, but that is the Screaming Cauldron, and I hope it inspires you to do other proximity effects for Halloween. Certainly you could use this for things that scream or move out of a bush, in a can. Anything pretty much is the sky's the limit for Halloween as far as setting up proximity sensors, because you know you got a steady stream of people coming in. But this one I thought was pretty fun because it allows us to use the reaching in of the hand to spawn the effect, and it's also kind of fun to use the little trinket along with the audio effects board. So check out the Learn Guide when that comes out in a couple days, and thank you so much. I'll see you next week, same time.